Alright, this is round 8 of LeetCode under an hour. Yeah, started. Alright, there we go, finally. Set the timer. Alright. Given arbitrary nums in which exactly two elements appear only once and all the other elements appear exactly twice. Okay. Find the two elements that appear only once. Okay, you can try the answer in any order. Sure. This right now runs in linear runtime complexity and uses only constant extra base. Okay. It's nice that they've provided this because that means it's pretty easy to figure out what we're supposed to do. I'm thinking two-pointer, but let me just look at the examples first. So we're trying to find the unique elements essentially. Okay, pretty easy to understand. Now, first thought is hash all of it, but we can't because constant extra space. Could sort it. That's not runtime complexity though. That's not linear. So, that is interesting. There are two very annoying constraints, I will say. Let's see, does the nums length tell us anything? No. What about the values? No, the values are just any integers. Each integer in nums will appear twice. Only two integers will appear once. Okay. That is a bit difficult. Simple problem statement though. I'm saying constant extra space. So can't be O of n, but I can store like one or two numbers. Any order. Should I process it? This is why I'm thinking two pointers, because of the any order. But due to the fact that the order doesn't mean anything, it's hard to justify moving a pointer. Can I say something like 1 is equal, I guess x is equal to our first number, which will, it's an integer array. Let me write 0. Well, I don't want it to be an actual number, so let's write float infinity. And the same thing for y. Alright. And return xy. If you can't tell, I'm stalling a little bit. I really don't know how I'm supposed to do this. Yeah. Okay. Linear complexity, yet constant extra space. Let's think, maybe let's do 2 runs. Alright, 1 forward, 1 backward. I'm gonna do that in constant time. And how would that help me? Or maybe I can do like a double pointer situation, or like one slow pointer, fast pointer. So like I have a pointer here at 1, and another pointer here at 2. This one moves twice as fast. That's the canonical way of solving the circle problem. But I'm trying to see, does that run in efficient time? like the idea of having multiple pointers. So I do think I will do that. Question is, how should they move? Assume you have a pointer here at 1. Move one pointer to 2. Check if 1 is equal to 2. If it is, okay, check if 2 is equal to 1. If it is, then we can just consider only this array. If it isn't, then they're both still valid options. Constant extra space is interesting. Everything I can think of uses space of length n. This is tough. And I can't even write something at all. It's really just algorithms, nothing else. It's just creativity. Let's see if I can try to come up with something. Let's start with an easy case. Let's make it 1 0 0 1 3. Okay. Let's think out that double pointer idea. So let's say I have a pointer at 0 and a pointer at 1. Check if they're equal. If not, then I move each one up by 1. No, if they are, then I just pop both of them. If not, I move them accordingly. I move... Okay. Does that work? Okay. So I'm along the 2-point strategy, right? Let's say this starts at 0. This starts at 1. Let's call this slow. Let's call this fast. Right? While true. Essentially if, what is it? What's the name of it? Num slow equal to nums fast, then nums dot hop if I pop it, then I have to adjust the indexes accordingly. Don't want to do that. But then again, how do I check if the length is 2? It's easier if I just pop. Yeah, let's just do popping. Oh, okay. I can do nums that remove whatever the value is, right? Is that a Python function? I think I have to do it twice. That might be correct. No, I think remove loops through and finds the index, which would be a order of n operation, which I'm not allowed to do within a while loop. So that'd be n squared. Yes, I can't do that. So we'll just do num dot, okay. If, okay. For now, I'm gonna leave it, but check if slow is higher than fast and vice versa. And based off that, I either remove slow then fast or fast then slow, or slow then fast minus one, or slow and fast, slow then fast minus one, slow fast minus one, or fast slow minus one. Anyway, regardless, this else will be, how do I iterate? I say, let's say fast, so the slow pointer plus equals 1, fast pointer plus equals 2, right? So let's try to analyze what's happening, right? 0, 1. Or do I want odds and evens? I don't know why I said that. Right, so let's say I have, odds and evens. How does that work? No, I think 2 might be right. Let me see. I think it's something along these lines, but I don't know how to prove that it works. But it just intuitively, this seems like a solution. So 1 and 2, these are the starting numbers. Let me use my example. Here's starting numbers. And then it'll say no false. So slow will go to here, and fast will go to 1, 2, here. Okay, so false. So we'll go to here, fast will go to, where was fast? It was here. And it goes 1, 2, and it'll go 1, 2 here. Check. So thing, and then I'll go 1, 2. Check here. Doesn't work. 1 here. 1, 2. Okay, I don't know how. That just doesn't work at all. And if you think it makes sense, as in like 2 pointers, one of them somehow jumps around. How do you make it jump around in the right way? I don't think it can be one in the front, one in the back. So let's assume both of them. So maybe they both start in the middle, or they both start on the left. Let's say they both start in the middle. No. Let's say they both start right here, right? 2. Then they have to decide left and right, which I don't want to do. Okay, they both start on the left. Okay, let's say we go until, right, O of n until we find the next one, right? In which case, we remove both of them. And checking the next one, we'll take another O of n minus 1, or n minus 2, which eventually becomes n squared. What if the slope pointer moves up by 1? The slope pointer stays the same. Fast pointer moves up by 2. I don't understand. How that even benefits me. Unfortunately, hash maps are not constant extra space. That would make this so easy. Okay, let's try to change this up a little bit, right? In which two elements appear only once, and all the elements appear exactly twice, right? So what I've been doing is I've been trying to identify which elements appear exactly twice, remove them, and then eventually I'll be left. And then when it's 2, I can just return them. Let's try to flip the script. And is there a way I can immediately identify if something appears once? Well, yeah, but I'll take an O of n check. Does that help me? Let's say I pick this number. Is it worth it to do O of n just to check this? No, it's not. But can I store some information along the way? Let's see. Not in constant extra space is the problem. What? What's an algorithm that runs in O of n, but use constant space? What? Can I try to make this into a graph problem or something? Like, let's assume each number is like a node. So 1 points to 2. I mean, what does that even mean? See, the problem is that I can't. I'm storing which numbers have already been created or are already present by creating these nodes. I can't store the numbers that are already created. That I've already seen. Well, I can't store all the numbers I've already seen. I can store like 1 or 2 or 3, right? Like some finite number. Let's say, right, as you're progressing, you check, there's a pointer that passes through, and it checks whether the number next to you is equal. And then if it is, then it removes them both. Otherwise, it switches them. Okay? So 1, 2, 1, 1. Does that do anything? I don't know if that helps me. Let's right. So like, let's say I had this, right? And then I would remember like this, and it would switch 0 and 1. Now check again, and it'll switch 2 and 1. Now check again, I'll switch 3 and 1. Check again. I'll switch 0 and 1. And then I'll remove these two. Alright, I guess I'll keep it here. Then I'll remove these two. And what, does that guarantee somehow that this is in the middle? I highly doubt it. I'm willing to try though. Can I somehow say if it's equal, you move them both, but if it's less than, you keep it on the side. So I'm kind of sorting it. Let's try experiment, right? Same thing. 1 0 0 1. So it's not equal, but since 0 is less than, you switch it. Otherwise, you'd keep it the same. So 1 2. If it's equal, you'd remove it. Otherwise, you keep it the same. So it's 1 2 here. And then you compare 2 and 3. They're not equal, but you leave it because 2 is less than 3. So now, so from here, I will say I'm liking the strategy. This is sounding good. So 0 3. You switch it because 3 is bigger than that. And then these two, check. They are not the same, so you switch it. So 1 3. Okay. Does that tell me any interesting information? Well, can I somehow guarantee that when I check on the leftmost and the rightmost, or can I check, is it somehow guaranteed that this index and this index are different? Again, highly doubt it, but I'll try. Oh, I need to try with this example. Okay, compare these two, leave it. Compare these two, we'll move it. 1 2. Oh wait, I don't remember if I... Okay. Compare these two. These two, leave it. These two, we switch. And then we don't compare backwards. So just leave it like that. And compare 2 3, leave it. And I go 3 2 2 3. And I go 3 5, and we leave it. I recognize that I'm bubble sorting right now, but is there a way that bubble sorting helps me? One pass of bubble sort helps me. What if I went backwards, one pass backwards of bubble sort after I go forwards? Let's somehow fix it. So this is the end goal, right? I want the biggest ones here. Let's do this again. 3 1. We leave it. This is the backward pass. I guess I'll... So we leave it. 0 1, we leave it. 0 2, move it back. 0 1, move this. Not fully sorted, which obviously I guess I shouldn't have expected. But it'll remove this. With it. think it will from my memory. Does this tell me anything? Let's see here. The backwards pass. What's the result of the backwards pass? Is there a way I can compare the indexes? If your index stays the same, maybe that doesn't make sense. Okay, wait. I'm mainly just trying random things right now, but that's where I'm at currently. Can't logic through this. This is a forward pass of the example. And now we're going to do a backwards pass using the same starting example. So 1, 2, 1, 3, 2, 5, right? We leave this. So that's fine. 2 and 3 we move. 2, 3. 2 and 2 we leave, 1 and 1 leave, and essentially that's it. Right? Let's say compare these two. 1, 1, 2, 2, 3, 3. Okay, this is looking. Wow, they match up. That's amazing. I don't know what information that would tell me. I mean, I need a worse example. So we're gonna use this. Right. For a pass, it would be. Move this. So it'd be 0, 1. Leave this. I'll leave that. Move this. 0, 3. Move this. 1, 3. Okay. Backwards pass. This is fine. There we go. This is fine. I don't know what this is supposed to do, to be honest, because all these forward and backward passes does is it really just ensures that the maximum's on the right side and the minimum's on the left side. That's all it does. And then it does some shuffling. That shuffling, I don't think it can tell me anything useful. Damn. Let's think along the lines of sorting algorithms. Okay, in which two elements appear only once. All other elements appear exactly twice. Exactly twice. I need to make use of this somehow. Is there any property I can use? Exactly twice. I'm really tempted to split it, but I can't. Can I binary search somehow? Can only do it once. or not once, but what? I'm so confused. Okay, let's say I assume the first two are the two integers. Then I have n minus 2 elements to deal with. What can I do with that though? I could binary search for the first number. Let's say it works. No, I have to, in order to binary search, I need sort. I can't even do binary searches. I could O of n search for the first number. Seems kind of dumb, but I could do it. And then also for the second number. It doesn't tell me anything. I need to gather information as I'm doing these passes. But how? Can you gather information? Okay. Without storing anything, the only way to gather information is the order, right? Or maybe one or two extra values. Everything has to be in place, essentially, but I don't know how. The order. How can the order help me here? Let's say I subtract the first number from all of them, right? If a number equals 0, right, then I abort, remove those two numbers. Sure. Then I repeat that process. That doesn't do anything for me, order-wise. So we'll say same thing. Subtract 1 from each one. So the first number from each. No, it's order. Come on. Say I take 3 numbers, the first 3 numbers. Of those 3 numbers, if... Oh, I like 3 pointers. Hold it. Wait up. So if I have 3 pointers, right? So the first 3 numbers. Because everything's sort of exact twice, either 2 of them have to be the same, and like in this case. Wait. No, I don't think that's right. But I'll think it out, because I was thinking somehow either 2 of them have to be the same, or I guarantee that one of the important numbers is in that section. But that doesn't work, because it only works in the same because there's 6 elements. If this was, for example, 1, 2, 3, 4, and then 4, 3, 2, 1, and then 5, 6, that wouldn't work. So let's say I had given a num's length, I had n over 2 pointers, right? So 1, 2, 3, 4, blah, blah, blah. I can guarantee that it's either all pairs or all numbers that have pairs. No. Not all of the... Oh, because it's n over 2, right? All of these numbers... Either... All these numbers can have pairs if they're paired with themselves. Okay, the only scenario where all these numbers have pairs is if there's one pair inside. There's at least one matching set. Otherwise, if there's no... How can there be no matching sets? 0, 1, 2, 3, 6, 7. No, 0, 1. Yeah, 0, 1, 2. 2, 1, 0. It's impossible. It's 0, 1, 2. Yeah. So if none of these numbers have a matching set within them, then that means one of them must be the important number, right? Yeah, one of them must be the important number. Okay. What do I do with the information? Well, I don't know. Can I somehow... I don't know how to do it. I might have to call this off right now, to be honest. I'm just lost. Oh my god. I just don't know where to go from here. Let's pursue the slow and fast again, I guess. So, slow, fast. Let's try the same number. Slow one goes to 2, fast one goes to 1. They are not the same. I guess we can switch them, right? Again, I don't know what this is going to do, but I'll do it. So, let's say you switch them. Then I get... So I basically try to sort, but then with the slow, fast methodology. So 1, 2. This is slow, this is fast. So we'll go here, fast will go 2 to this guy. It's the same. So we'll remove it. These two, they're different. So we move on. And then we loop around from the back. Wait. Let me pursue this a little bit more clearly. So 1, 1, 2, 3, 2, 5. So let's say we start with this. Slow would be equal to 0. Are they the same? No. Are they in ascending order? Yes, so we don't touch it. This would be 1, this would be 3. 0, 1, 2, 3. Are they in ascending order? Yeah. So don't touch it. 2, 4, 2, 3, 4. Ascending order, yeah. 3. Oh wait, this isn't supposed to be 4, it's supposed to be 5. So 0, 1, 2, 3, 4, 5. Sure. Now what am I supposed to do? Do I make it loop around? Let's say I found the minimum, right? And then I have the minimum of the whole data set. Wonderful. Can I somehow use this to obtain in at most some constant C number of passes the unique ones? Well, let's assume I have the maximum too. So either at the minimum okay, let's say I store the minimum index, right? And another index, which I'm going to use to store the next minimum. I go all the way to the end, and I look for the next minimum. I find it. That's great. Because I found a pair. Do I remove it? Yeah, that makes sense. So remove. then so same process to get the next minimum. Which is then what? I'm lost. I'm so lost. Unfortunately, I'm gonna call it here. I think wasted 45 minutes doing nothing. Completely stumped. Devastating failure.